Good morning, chemistry students. My name is Mr. Adam. This is chemistry. Today is the 28th of April. It is a Tuesday and it is a day 4 in our rotation. So good morning, everybody. Happy Tuesday. I hope you're all doing well, enjoying the beginning of the 5th week of school at home of online learning. It's hard to believe still, but this should be day 22. So basically, we've been at this for a whole month, which is crazy. Today, not a ton to talk about. I mostly said everything I wanted to say yesterday in our 18-minute video all on electron domains. So if you're looking for help on today's assignment, if you're not completely understanding everything, if you for some reason don't pass that assignment and get less than a 5 out of 10 on that, or 5 out of 10 or less, then go back and watch yesterday's video, see if that explanation about electron domains helps you. Today we're going to do one example problem with electron domains with drawing a Lewis structure, figuring out how many electron domains there are, and then figuring out what its shape is. Miss Marnick's video, of course, is also a great resource. She really explains these things and breaks them down well and usually does example problems pretty well too. So, not a whole lot to talk about today. Just a quick reminder that I am going to be hosting office hours every day from 1:30 to 2:30. I won't be able to do that on Thursday. I have a commitment during that time, but every day, if you need help, if you have questions, if you don't quite get the assignment, come on between 1:30 and 2:30 for 5 minutes, ask me a question, get some clarification on something. It's better than sending email to actually talk in person. So be there for that if you'd like to do that. So for today's lesson, like I said, I just want to do one example problem. So with these electron domains, what we're doing is we're taking a molecule and trying to figure out what its shape is like, how the atoms are arranged around it, and what kind of three-dimensional shape that actually creates. So we have to look at an atom we have to look at a molecule or one atom bonded to multiple atoms to figure out that kind of shape. So for this example problem, we are going to look at ammonia Nh3. This is a chemical that we do a lot of example problems with for a good reason. So this is ammonia Nh3. So in order to figure out what this looks like in 3D, in 3 dimensions, we first have to make this thing called a Lewis structure. We first learned how to do this about 2-3 weeks ago in lesson 2.4. And so we have to make a Lewis structure for this, Nh3. So how do we do that? Well, there are a couple ways to do this, right? First thing you could do is find all the number of valence electrons and then create a Lewis structure from that. Or you could look at N and H and know that those are both the honk 1, 2, 3, 4 rule, so they should both form a certain number of bonds, right? Okay, let's do the Lewis structure method. So let's count up the total number of valence electrons. N here is going to have 5. So, is that a 5? I think it's a 5. And H is going to have 1 each times 3. So that's going to give me a total of 8 valence electrons. Writing upside down and backwards is hard. So there's going to be 8 valence electrons on H3. Okay, that's our first step. Second step is to determine the central atom. And if you look at this, what atom is there only one of? What kind of element is there only one of? N, right? So we're going to put N in the center, right? And then all the H's are going to go around that. Okay, all the H's are going to go around. So our next step is to start filling in electrons for bonded pairs. 1, 2, 3, 4, 5, 6. So I use 6 valence electrons there, and I use 2 for each bonded pair and connect each hydrogen to the central atom N, right? So this hydrogen's connected, this hydrogen's connected, this hydrogen's connected, all with 2 electrons, all with 1 bonded pair. So I use 6 electrons there. Now I have 2 left, right? Went from 8 to 2. And so those last 2 are going to go on this nitrogen here, right? Hydrogens are full. They only need 2 each, so they're good. My nitrogen here has 1, 2, 3, 4, 5, 6, 7, 8. And we have used all 8, so we have 0 valence electrons left. So this is my Lewis structure for Nh3. Now, if I take my purple marker and black marker, I'm going to figure out how many bonded pairs there are on N and how many lone pairs there are. So bonded pairs, there's 1, 2, 3. 3 bonded pairs between N and H, right? Okay, so there are 3 bonded pairs there, and how many lone pairs? How many pairs are not connected to an H or just by themselves on one side of it? here, right? This lone pair is all alone. They at least have a partner, they're at least paired, but they are all alone. So we have 3 bonded pairs and 1 lone pair here. And so from that we can figure out the number of electron domains and how this molecule is going to be shaped, okay? So we have 3 LP, 3 lone pairs, right? And we have 1, I'm sorry, that's 3 bonded pairs. My mistake, got all excited. All right, we have 3 bonded pairs and we have 1 lone pair. Okay, if you add those together, you get the total number of electron domains, and we'll write that in red. So we have 4 electron domains. Remember that E with the minus symbol means electron. Okay, so we have 3 bonded pairs, 1 lone pair, and 4 electron domains. So if we're making a molecule with that, right? What we're gonna do is we're gonna start with our central atom here, right? We have the central atom. For each bonded pair, we're gonna connect another atom because that bonded pair is literally connecting another atom. This represents the 2 electrons connecting those atoms together. Gonna connect another one and another one, right? So no matter how I connect those on this atom, it doesn't matter. You'll see that I always have 3 bonded pairs and 3 atoms connected. And when you do that, it kind of forms this triangle shape. Now it's not a perfect triangle. If you look at it 3D, you'll see that that middle atom sticks up above the other atoms a little bit. It's 3-dimensional, right? It forms kind of a pyramid. Okay. What about the last electron domain, right? What about that last pair of electrons, that lone pair that was on top of nitrogen, right? We can't forget that. We can't forget that. So we have to put electrons there, this line representing electrons. But remember that we don't actually see that lone pair when we see this in 3D. So this ends up being covered up, right? So when we see this molecule, this is literally all we see. We see the central atom and then 3 atoms connected to it that are kind of pushed down by this invisible lone pair up here. So what kind of shape is this? We said it looks like a triangle, right? Kind of imagine a triangle around this, but it's not in 2 dimensions. It is a pyramid. So what shape name means triangle pyramid? If you look in your book, you look in your notes, we got tetrahedral, we got trigonal pyramidal, we got bent, we got linear. The one that means triangle pyramid has 3 atoms is called trigonal pyramidal. So starting with NH3, we make a Lewis structure. With the Lewis structure, we figure out the number of bonded pairs and the number of lone pairs, 3 and 1. Then using that, we can create a model, or we can look and see that 3 bonded pairs and 1 lone pair forms a trigonal pyramidal shape. All right. So that's an example of how you would do that, how you'd work all the way through that process from the beginning. You will have to do some problems like that in today's assignment and in Thursdays. So work on that. Keep working hard, guys. I will see you all tomorrow. Stay safe, stay positive, keep working hard. Let's get a 1, 2, 3. Clap on me. See you tomorrow.